some rational equations. So first thing we need to do is we need to get it so that they all have the same denominator. Okay, and how we're going to do that is to figure out what we have here, what they share in common, and what each one is missing. So if I look here, x squared minus 25, we know that that is going to simplify to x plus 5, x minus 5. All right, so now I'm going to go ahead and I'm going to say, okay, well, they all need to have that then. And you notice this one has x plus 5, this one has x minus 5. So we're just going to multiply by whatever it's missing. Well, the first one is not missing anything, so we don't have to multiply by anything. Okay, this one, well, we need an x minus 5 in the denominator. So we're going to multiply by that. All right, now we're going to go to our last term here, and we're going to say we got 1 over x minus 5. And this one is missing x plus 5. So I'm going to go ahead and now I can cancel out all the denominators. All right, now we're just going to solve for the numerator because they are now all the same. So I can now rewrite this x minus 3. Well, 1 times x minus 5 is just x minus 5, right? And then that is equal to 1 times x plus 5. So since it's times 1, it's pretty easy. Now we're just going to combine terms. We got 2x minus 8, and then we have x plus 5. All right, so I'm going to go ahead and simplify here and solve. I'm going to move this x over to the other side. That's going to cancel. That's going to give me x minus 8 equals 5. Now I just move the 8 to the other side by adding 8 to both sides. And I got x equals 13. All right, now you always want to check for an extraneous solution. If it gives you a 0 in the denominator, then it's extraneous. But if you look here, I plug in 13, any of these denominators, we're good, okay? And if it, x squared minus 25 is x plus 5, x minus 5. So actually, if you just try these two, you know you're good. Okay, so number 1 is done. Okay, let's do one more of these. So here's our second one. All right, so now we have kind of a similar problem, but it's going to work out a little differently. We got x squared minus 1. Well, that just factors to x plus 1, x minus 1. Okay, so you always want to look at factoring any of the denominators that you can, so you can see what the other ones are missing. All right, so now I can clearly see that this first one is missing x plus 1. So I'm going to go ahead and multiply by x plus 1 on the numerator and denominator, right? So it's essentially just multiplying by 1. This is why it works. Okay, now let's put these in parentheses just for good measure, because we're going to multiply them out in a minute. So now this one is missing x minus 1. So I'm going to go ahead and put that here. Okay, now I'm almost done here. I got 4 over x squared minus 1. Now I can go ahead, well, I'm not quite done, but I'm ready to cancel out the denominators because they all have x plus 1, x minus 1. Okay, so I'm going to go ahead and cancel those out, and now I'm going to have x plus 7 times x plus 1 plus x minus 1, x minus 1 equals 4. Okay, so now I got to multiply these out so I can solve for x. And remember, when you multiply out, you're distributing. Okay, so we're going to go ahead and distribute these. And when we do this, we're going to get x squared plus 7x plus 1x. Well, let's write that out. 7x plus x plus 7. Okay, so that's the first part here. Then over here, when you multiply x minus 1 quantity squared out, you're going to get x squared minus 1 times x minus 1 times x again for this one. And then minus 1 times minus 1 is actually positive 1. And that's all equal to 4. Okay, so now I'm going to combine. And when I combine, I like to cross out things. I like to look at x squareds first. I'm going to cross those out because that's going to, when I add 1 plus 1, that's going to give me 2x squared. Okay, now I'm going to combine all my x's. I got 7x plus x is 8x. Minus x is going to leave me with 6x. Okay, so that's going to give me 6x here Now these are all crossed out. And now I can just worry about the 7 plus 1. And that's going to give me 8 here. And then I have 4 here. Okay, now I'm almost ready to solve this, but I need to move the 4 over here. So I'm going to go ahead. You always want to have your equation equal to 0 to solve a quadratic. Okay, so I'm going to go ahead and rewrite this. Okay, now, this looks like you have to do factoring by grouping, but notice you don't have to do that. You can just divide 2 out of every term. Okay, so I'm going to factor 2 out of every term is the better way to say it. So I'm going to factor 2 out here. This is going to be 3x, and this is going to be 2. Okay, now remember, if you're just solving for 0, you can just divide by 2 again, and now you're just actually solving this quadratic. Okay, so now I'm almost done here, and I'm going to have x plus 1, x plus 2 equals 0. So I'm going to write my solutions up here at the top so we can see them with the function, and that's going to be x equals -1 from here, and then x equals -2. Okay, now, last thing you got to do is you got to check for extraneous solutions. Now look, if I input -1 here, -1 plus 1 gives me a 0. So that is an extraneous solution. We're going to cross it out and put ES. -2, we're actually good. That one works fine because it doesn't give me 0 anytime I plug it in. Okay, so that's x equals -2. And so now we got that, and now we're done. So there's actually only one solution that works, but you do want to notate the extraneous solution so that I know you got both parts there.